Yay!
Yay! All right, let's try another quick example of angular momentum conservation. And this time what we're going to do is look at a turntable. So I've got some large turntable, maybe 2 meters in radius, mass of 12 kilograms, that's spinning at a certain rate. Let's say that it's spinning at 12 revolutions per minute. And then a cat jumps on. They'll do that. So let's say that the cat is 4 kilograms and the cat happens to jump on carefully 1.5 meters from the center. So the question is, what is the new rotation rate after the cat jumps on? Let's see what happens. The principle is, as always, that Li is Lf. So, always you can write this down. I omega initial is I omega final. All right. And what we're after is that omega final, right? So, omega final is going to be the initial divided by the final times the initial rotation rate. Okay. So the trick is we have to write down what the moments of inertia are. All right, so what is the initial moment of inertia? Well, it's just a rotating disk. It's just a turntable. So thinking back to what we've done before, the moment of inertia of a spinning disk is just 1/2 mr squared, right? Okay, after the cat jumps on, then what do we have? Well, then we have, it's still a spinning turntable, still the same big M and big R, and now we have a point mass. That cat is just sitting out there some distance away. So I just add the two together, right? It's like adding masses together. I can add rotational masses together. So I've got the original thing, 1/2 mr squared, plus now I've got a point mass sitting out there at 1.5 meters away. So I've got little m times little r squared. There I go. And now I multiply times my initial rotation rate. That's all there is to it. So now I can plug all my numbers in. And when you do that, what you get is something like, what did I get? It's about 0.72 times the initial rotation rate, 12 RPM. Converting from 12 RPM to omega, we said that was what you roughly just move the decimal point, right? But it's just a common factor on both sides of the equation. So it's really 0.72 times 12 RPM is what you'll get. And when you finish converting, you'll get something like, what is that, about 8.7 RPM is going to be the final answer. The main point is, the cat jumped on, right? We got more mass to spin around, and so what you'd expect is that thing's going to slow down. And sure enough, we went from 12 RPM to 8.7 RPM after the cat jumped on. So yeah, that's pretty much exactly what we expect. Neat.